Hello everyone, myself Sindhushri, Department of Mathematics, MITM Mysore. So the last class we have studied the indeterminate forms, there is certain form of the indeterminate forms. Today we will discuss the partial derivatives. You know the partial derivatives has wide range of applications in our daily life. It is used in the fluid mechanics and the SOM, it is also used in economics, and using the partial derivatives you can solve the heat and wave equations also. So let us go to the partial derivatives. So partial derivatives, consider the function z equals f of x comma y, where z is the function, x and y are the variables. So the partial derivative means, suppose you consider differentiation of z with respect to x keeping y as a constant, you denote the partial differentiation of z with respect to x by del z divided by del x. Here keeping the y term constant. Second one, suppose the partial derivative of z with respect to y keeping x term constant is denoted by del z divided by del y, and these are called the first order partial derivatives. So with respect to x and y. Similarly, the second order partial derivatives are denoted as the first one, z with respect to x del square divided by z del x square. This is the second order partial derivative of z with respect to x. Similarly, you can consider the second order partial derivative of z with respect to y, del square z by del y square. Similarly, the second order partial derivative of z with respect to x and y, this is same as del square z by del y del x. So these are the partial derivatives. The partial derivatives can also be denoted as the first one, you consider this as zx, this is zy, zxx, this one. Similarly, this one zyy, the third one zxy, this is same as zyx. For example, you consider the function z with respect to the two variables x and y, x cube plus y cube 5x square y square. So the first partial differentiation of z with respect to x, keeping the y term constant, it is del z divided by del x equals, you have to differentiate with respect to x keeping the y term constant. So the first term differentiation, x cube is 3x square. Since the y is constant, the differentiation of y is 0. Next, here the y square and the phi are the constant terms. You have to differentiate x square, this 2x. This is the partial derivative of z with respect to x keeping the y term constant. Similarly, the partial derivative of z with respect to y equals keeping the x term constant. Since the x is constant, the derivative of constant is 0. The second part, y cube differentiation, it is 3y square plus, since the x is constant, keep the 5x square as it is, then differentiate the y square, you will get the 2y. This is the partial derivative of z with respect to y. Similarly, you can take the second order partial derivatives. For example, I consider this term del z divided by del x. Suppose you differentiate this one again with respect to x, you will get the second order partial derivatives, del square z by del x square, keeping the y term constant again. So it is x square differentiation 2x, multiplication of 3 will get the 6x. Similarly, second one, here the 10x 10 y square is a constant. You have to differentiate x. X differentiation is 1. So the second order partial derivative with respect to x is obtained by the first order. Similarly, if you differentiate this del z by del y with respect to y again, you will get the second order partial derivative of z with respect to y. So the first differentiation, it is 6y, y square differentiation 2y, multiplication of 3 will get the 6y. Second term, here the x is constant, so keep this term as constant term. So it is 10x square. The y differentiation is 1. This is the second order partial derivative of z with respect to y. Last one, the partial derivative of z with respect to x and y. Either you differentiate this term with respect to y or differentiate this with respect to x. Both are same. So I take the first part. I differentiate the del z by del x with respect to y. You will get the second order del y into del x. This equals, you differentiate this one with respect to y, keeping x term constant. Since x is constant, this differentiation you will get 0. Second part, here the x is constant, you keep the 10 into x as it is, differentiate the y square, you will get the 2y. So we will get the answer, it is 20xy. This is same as del square divided by del x del y. That is, you have to differentiate the del z by del y with respect to x, keeping the y term constant, you will get the same answer. My next topic is the total derivative or exact derivative, both are same. So consider the function u equals f of x comma y, here x and y are functions of u. Then the total derivative of u or exact of u is defined by du equals del u divided by del x into dx plus del u divided by del y into dy. Here you have the two parts. The first part is the total derivative of composite function with respect to the single variable or the total derivative of composite function with respect to the two variables, that means containing two variables. So first I take the first part, the total derivative of composite function of single variable t. I consider the same function u equals f of x comma y. Here x and u is a function of xy and x and y are the functions of single variable t. Suppose I consider the same term, u is a function of the x and y are functions of the single variable t. Then u is called the composite function of the single variable t. That is, the same formula is reduced to, so u is a composite function of the single variable du by dt, del u divided by del x, dx divided by dt. This is how the product plus del u divided by del y, dy divided by dt. So I consider the same function here, u is a function of xy and the xy depends on the single variable t. Then the composite function of the single variable is defined by this formula du by dt, del u by del x, dx by dt. Here the del u by del x is the partial derivative, d by dx is the usual differentiation of x with respect to the variable t. Same term, it is del u divided by del y, it is a partial differentiation of u with respect to y. Then the usual differentiation of y with respect to t. The first example, I consider the function z equals u square plus v square, u equals at square, v equals 2at. Then you have to find the dz divided by dt. Z is depend on the two variables u and v, and u and v depends on the single variable t. So it is a composite function of the single variable t. So you have to find the dz divided by dt. First to construct the formula. So here the z depends on, so write the solution. Here the z depends on the single variable t. First you write the del z divided by del u, du divided by dt plus del z divided by del v, dv divided by dt. This is the formula. So the first one, del z by del u is a partial derivative of z with respect to u. So since it is the partial differentiation, so with respect to u means you have to keep the v term constant. So the first differentiation with respect to u, so u square differentiation to u, since the v is constant, the differentiation 0. Next, it is usual differentiation of u with respect to t, t square differentiation, it is 2t. So keep the a as it is, you will get the 2at. Plus second part, z with respect to v, you have to keep the u term constant. So the first differentiation, u square differentiation 0 plus v square differentiation 2v. v with respect to t, it is usual differentiation. So differentiate this, 2a into the differentiation of t is 1. You simplify this. So the first part, 2 into 2, you will get the 4at into u. Second part, it is 4a into v. So it is dz divided by dt. So you have to represent, since it is dz divided by dt, you have to represent z in terms of t by substituting the u and v. So for u you substitute at square, that is a given problem. It is at square plus 4a, v you substitute 2at. So du divided by dt, sorry, dz divided by dt equals, it is 4a square t cube plus 8a square t. This is the answer. So the next problem, find du by dt where u equals y square minus 4ax, the given x equals at square, y equals 2at. So here first to see the terms. Here the u is a function of the two variables x and y. X and y depends on the single variable t. Therefore, u is, write in sentence, therefore u is the composite function of the single variable t. First you construct the formula. Du by dt, du divided by dt, it is del u divided by del x with respect to x and y, del x divided by del t, sorry, dx divided by dt plus del u divided by del y, dy divided by dt. So the first term, you have to differentiate u with respect to x, that is a partial differentiation, keeping the y term constant. Since the y term constant, the differentiation of this 0, y square, you will get the 0, x differentiation 1, since you have the negative sign, you write the minus 4a. Next, x with respect to t, differentiate the t square, you will get the 2t, so 2at you will get. Similarly, next part, u with respect to y, differentiate this with respect to y, keeping the x term constant. So y square differentiation 2y, since x is constant, the differentiation is 0. Next, dy by dt, y you have to differentiate with respect to t, so we will get the 2a into 1. So the next substitution, you substitute for this x and y. So in the first part you don't have the x term, so this equals, you will get negative, and since you have the negative sign, minus 8a square into t, Second part, here you have the 4 a into y you substitute by the given term, it is 280. So this equals minus a square t plus, simplify this, plus 8a square t. Since both have the opposite sign, you will get the total derivative of u with respect to t is 0. Is the problem. In the next problem also, they given the function u equals sin x by y, where x equals e power t exponential and y equals t square is a polynomial. You have to find the du divided by dt. So here first to see the terms, u is a function of the two variables, x and y depends on the single variable t, therefore u is a composite function of t. So you have to first to construct the formula u with respect to t, that is solution du divided by dt equals del u divided by del x dx divided by dt. This is the first part, plus del u divided by del y dy divided by dt. And the formula is depends on the number of variables. Suppose you have the two variables, this formula holds good. Suppose you have the three variables x, y, z, then you consider the one more term del u by del z dz divided by dt. So you have to add the number of variables. So the first one u with respect to x. So differentiate u with respect to x keeping the y term constant. So first you differentiate this trigonometric term, sin differentiation, it is cos x by y. Next differentiate x by y with respect to x keeping y term constant, keep this 1 by y as it is, differentiation of x is 1. So we will get 1 divided by y. So this is the first part, del u divided by del x. Next dx by dt, you have to differentiate x with respect to t, e power t differentiation e power t. Next second part, u with respect to y. So as usual, you differentiate the sine term, we will get the cos x divided by y. Next differentiate x by y, since it is partial derivative of u with respect to y, keeping x term constant. So you keep the numerator x as it is, differentiation of 1 by y you have to consider, 1 by y differentiation minus 1 by y square. So you will get minus x by y square. So dy by dt is 2 into t. Next substitute for x and y, you will get the answer. So represent du by dt in terms of t. So cos first term 1 by y you have, first you consider this e power t, 1 divided by y you substitute t square. Then keep this cos x by y, for x you substitute e power t, y is t square. This is the first part. Similarly second one, here you have the negative sign, minus 2 into t you keep it. For x you substitute e power t, denominator, y square you have, the y square you substitute t square whole square. Next you keep this cos x by y, that is e power t divided by y square as it is. Cancel this 1t. So here you have the common term, cos e power t divided by t square is a common term. In the first part you will get e power t divided by t square. In the second part it is minus 2 e power t divided by t cube. Sorry, it is t square. It is du divided by dt. So So previous part you have studied the composite function with respect to the single variable t. Here the next part is the composite function containing the two variables. The same function I consider. Suppose u is a function of the two variables x and y, and x and y depends on two variables r and s. In the previous case, x and y depends on single variable t. Here the x and y depends on the two variables r and s. Then u is said to be composite function of r and s in terms of x and y. So you have to consider the formula u is a composite function of r and s in terms of x and y. You have to consider the formula. Since here we use the more than two variables, for the construction of the formula you use the partial derivatives. So u is a composite function of r and s. So you have to consider the formula u with respect to r and u with respect to s in terms of x and y. So the first formula is del u divided by del r. So del in terms of x and y, so multiply and divide by x, you will get the first part. So u with respect to y, del y divided by del r. Similarly second part, del u divided by del x divided by del s plus del u divided by del y divided by del s. This is the second part. For example, I consider the function z equals, if z equals f of x comma y, the given x and y, here x and y depends on u and v. Next you have to prove that del z by del u minus del z by del v equals x into del z by del x minus y into del z by del y. First you construct the formula. Here you see the terms z is depend on the two variables x and y depends on another two variables. So here the solution, z is a function of the two variables x and y. Next x and y depends on another two variables u and v. So z is the composite function of u and v in terms of x and y. So in terms of x and y you have to consider. First to construct the formula. So del z divided by del u and del z divided by del v. So the first part is del z divided by del x divided by del u. Second part del z by del y divided by del u. Similarly second term del z divided by del x divided by del v plus del z divided by del y divided by del v. Next, the partial differentiation of z with respect to x, you keep this term as it is, del z divided by del x. Next, x with respect to u. So you have to differentiate x with respect to u keeping the v term constant. Since it is a partial differentiation, keep the v term constant. So e power u differentiation is e power u. The second part you will get the 0. Similarly, next term plus del z divided by del y with respect to u. So you have to differentiate y with respect to u keeping the v term constant. So the first differentiation e power minus u differentiation minus e power u, e power v differentiation 0. Next, similarly second term del z divided by del x. So x with respect to v you have to take the differentiation. So with respect to u, e power u differentiation is 0. E power minus v differentiation minus e power minus v. Second part del z divided by del y with respect to v keeping u term constant So the first part you will get the 0, second term e power v differentiation is a power v. So consider the LHS part, del z divided by del u minus del z divided by del v. You have to take the differentiation between these two. So the first part, so the first term e power u del z divided by del x minus e power minus u del z divided by del y. Second part with a negative sign minus, since you have the negative you will get the positive sign, it is e power minus v del z divided by del x. You multiply with negative, so this term become negative, e power v del z divided by del y. Next you keep this, so these, from these two you take the del z by del x as common term, so you will get the e power u plus e power minus v del z divided by del x. In the second part, so since you have both the negative sign, you keep the negative sign outside, minus e power minus u plus e power v del z divided by del y. So the first part you taken, so the e power u plus the first part e power u plus e power minus v, you consider this part as x. The second part e power minus u plus e power u, you consider the term as v. So we will get the result. So write it here. So this equals x into del z divided by del x plus y into del z divided by del y. This is your RHS part. So consider the next example. If equals, h equals f of y minus z, z minus x minus y, then you have to prove this part del z, del h by del x, del h by del y, del h by del z. So in this problem, first you consider the given functions in terms of another variables, or represent, I rewrite this problem as, first I take the part, let I consider this h function as f of u, v and w, where u equals y minus z, v equals z minus x, w equals x minus y. Next, now we see the terms. First, h is a function of three variables u, v and w, and u, v and w depends on another three variables x, y and z. So write that u is a function of, so I write that h is a function of u, v and w. U, v and w is a function of, are the functions of another variables x, y and z. So you can write h is a composite function of x, y and z in terms of u, v and w. So you have to construct the formula h in terms of x, y and z with respect to u, v and w. So I write the formula first. So the first term, first you have to write del h divided by del x in terms of u, v, w, del h divided by del y, same del h divided by del z. So first in terms of u, v, w means, so it is del h by del u divided by del x. These two should be same. Second part, del h divided by del v divided by del x. Next, del h divided by del w divided by del x. Similarly, construct the second one, second formula, del h by del u with respect to y. Second term, del h divided by del v divided by del y. del H by del W divided by del Y. Same, consider third formula. So H divided by del U divided by del Z, H divided by del V divided by del Z, del H divided by del W divided by del Z. So you have to construct the formula H in terms of X, Y, Z with respect to U, V and W. Now you solve this by taking the partial differentiation of U, V and W with respect to X, Y and Z. So the first part, I consider del H divided by del X. So del H by del X, this part, so del H by del U, next U with respect to X, since here you have the three variables, next U with respect to X, since you have the three variables here, X, Y and Z, first with respect to X, you have to keep the Y and Z terms constant. So the first one, U with respect to X means these two variables are constants, the differentiation are 0. So the first part, U with respect to X, the differentiation 0. Similarly, second one, del H divided by del V with respect to X, differentiate this, keeping the Y and Z constant. So this differentiation 0, X differentiation 1. Similarly, del H divided by del W. So W with respect to X differentiation 1, you have to keep the Y term constant, the differentiation 0. Similarly, you can write the other two parts. U with respect to Z, V with respect to Z, W with respect to Z. So the first part, del H divided by del X plus, I consider this as the LHS part, del H divided by del Y plus del H divided by del Z. This equals, the first part is 0, second one minus del H by del V, third one plus del H divided by del W. The second term, the first term is plus del H divided by del U, second term 0, del H divided by del W. The third term, the first term you have the negative sign, del H divided by del U, second term del H divided by del V. So del H by del V get cancelled. Similarly, H part is cancelled, W part is cancelled. Then you cancel these two, you will get the answer 0. There is your RHS part. So in the next example, I consider the same function H equals f of U, V, W. Here UVW depends on X, Y and Z. Then you have to prove this. X into del H by del X, Y del H by del Y, Z del H by del Z equals 0. So the first part, first to see the terms. Here H is a function of three variables U, V, W, and UVW depends on another three variables X, Y and Z. Therefore H is a composite function of the X, Y and Z in terms of U, V and W. This is same as the previous problem. You construct the formula first. This is the formula you have to consider. So first del H by del X, del H by del Y, del H divided by del Z. In terms of U, V, W, you construct the formula. So the first one, you keep the del H by del U as it is. U with respect to X, you have to differentiate U with respect to X first. Next with V with respect to X and W with respect to X. So with respect to X means you have to keep the Y and Z terms constant. Similarly with respect to Y, keeping the X and Z terms constant. Similarly, with respect to z, keeping x and y terms constant. So just go through the problem. So the first one, del h divided by del x, del h divided by del u. First you differentiate u with respect to x, keeping the y term constant, y and z constant. So you will get the 1 by y. You keep the y as it is not equal to 0. You keep this y part, so differentiation of x, you will get the 1. Similarly, v with respect to x, so you don't have the x term in the v, so the differentiation of this is 0. Similarly, del h divided by del w, so w you have to differentiate with respect to x, since x is in the denominator, you have to differentiate 1 by x, so 1 by x differentiation minus 1 by x square. Similarly, you can write other two parts. So the first one, del h divided by del u, u with respect to y, minus x by y square, del h divided by del v, v with respect to y, 1 by z, del h divided by del w, w with respect to y is 0. Similarly, last part, it is del h divided by del u, u with respect to z is 0, del h divided by del v, v with respect to z minus y by z square, del h divided by del w, w with respect to z, it is 1 by x. Since in the given part they asked to prove that the x multiplication of this, y multiplication and z multiplication of the last term, you consider the LHS part. So x into del h divided by del x, y del h divided by del y, z del h divided by del z. This equals, I write it here, this equals first term multiplication of x, you will get the x by y, you already have the y term, x by y, del h divided by del u, second part is 0, next term multiplication of x, you have the x square already, minus z by x, 1x get cancelled, del h divided by del w. Similarly, second part you multiply by y, so you have the y square in denominator, minus x by y, del h by del u, this part y by z, del h divided by del v, and the last part you multiply this by z, minus first term is 0, second term, minus y by z, del h divided by del v, last term z divided by x, del h divided by del w. So z by x with negative sign, this to get cancelled, x by y, this to get cancelled, and cancel the y by x, y by z with a negative sign. So RHS becomes 0, that is the given part. So these are the composite function of with respect to the single variable and the composite function containing the two variables. We will continue in the next class. Thank you.